In this video, we're going to talk about what to do with the error that you calculate with an analysis. So in order to calculate the error, I have another video that shows how to calculate data error of standard deviation, and really for any X and Y set of data standard addition, you can go and click on my video here. So what do you do after you calculate this U sub S, this standard error? Of course, it's been multiplied by the confidence interval as well, this T value. And so this is the T test value. We actually end up using this 2.365. So it's actually n minus 2 degrees. For the degrees of freedom, we had 9 data points minus 2. So with a 95% confidence level, we can say then, in this particular example, if the unknown was calculated to be 2.89 millimolar, out of that example that's in the YouTube video and from our textbook, it said that the error was 0.23 millimolar. A couple things to notice. I have 2 decimal places here, just like my value does, so you can't add more significant digits. Just because your spreadsheet got you more, you have to think about significant digits always and use the same units. And so I would think about the value that I've got now is not just an average, it's not just one value, but it's actually a range of values that I have confidence that it's somewhere between those. So that means 2.89 plus or minus 0.23 could be somewhere between 2.66 and 3.02. Well, if you have to compare this to another value, let's say your other value is 3.12 plus or minus 0.33 millimolar. Well, did I just get the same value? I mean, it looks different. The averages are different. That's the 3.12 versus the 2.79. So how do I know if they're the same? Well, I have to look at the error and the overlap. So I'm 95% confident that this is between 2.79 and 3.45. The other values were between 2.66 and 3.02. That's a significant overlap between these two numbers. And so I would have to conclude the fact that they're related and overlapped, that they're potentially the same number. Now take a number like 3.23 plus or minus 0.05, that would go from like 3.18 to 3.28. And so that's a very narrow distribution and wouldn't overlap. See, scientists start to think about numbers not as one value that you get out of your analysis, but a range. And this is a little probability distribution with confidence intervals noted. And so this is how we think of our values that come out of an analysis. It's not one thing because of the error that is associated with each test. And then when we're comparing it to another number, that number also is a probability distribution. So how do the two overlap? There's very little overlap, and then they're probably different numbers. But if that number has a pretty large overlap with the other one, probably the same. So this is how you should do your analysis when comparing results from either 2 different tests or 2 different unknowns or the same unknown. You get 2 different values. This test will help you think about it.